Imagine holding a pair of chopsticks, two wooden rods, about 25 centimeters long, with no hinges, springs, or circuit, yet able to lift a grain of rice with millimeter precision. With only slight finger pressure, you can grasp a delicate object weighing mere milligrams without crushing it. Then rotate it smoothly toward your mouth. In a mechanics laboratory, this structure would not be seen as simple. It is a finely tuned parallel mechanical system shaped by culture and physics. Chopsticks act as a third arm for humans, amplifying force at a microscopic scale through leverage, heat transfer, and controlled friction. They prove that engineering wisdom does not always lie in steel or silicon. Sometimes it hides quietly within two slender pieces of bamboo. Around 3,000 years ago, during the Shang Dynasty, archaeologists discovered bronze chopsticks in noble tombs used for cooking rather than eating. These early tools stirred boiling food inside bronze vessels, revealing an early encounter between human design and thermodynamic reality. Copper conducts heat at about 400 W mK, more than 1,000 times higher than bamboo or wood, making metal chopsticks dangerously hot within seconds. When the tip touched boiling water, heat rapidly traveled along the metal shaft, turning the handle into a potential burn hazard. Humanity therefore shifted from metal to organic materials like bamboo and wood, whose conductivity is only around 0.10 W mK. The cellulose fibers and tiny air pockets inside bamboo act as natural insulation, slowing the transfer of thermal energy toward the hand. Chopsticks thus became a product of biological energy optimization, maintaining distance from heat while conserving valuable material resources. In a world where firewood was precious, choosing low-conductivity materials became a survival strategy rather than a mere culinary preference. A well-designed pair of chopsticks depends not only on shape, but also on surface tribology, the science of friction and microscopic texture. Under an electron microscope, wooden chopsticks reveal landscapes of tiny ridges and valleys that increase grip on slippery foods. Metal chopsticks, with smoother surfaces and lower friction coefficients, require different ergonomic solutions to maintain control. Japanese designs often feature pointed tips suited for fish, while Chinese chopsticks are longer and blunt to share dishes on rotating tables. These variations are not aesthetic accidents, but examples of ergonomics, reflecting how material design adapts to cultural eating behavior. Even average length differences, about 25 centimeters in China versus 23 centimeters in Japan, mirror the physical layout of dining spaces. In this sense, chopstick geometry becomes a physical map of culinary culture, shaped by friction, biology, and social interaction. Eastern folklore once claimed that silver chopsticks could detect poison, a belief rooted in royal fears of sulfur or arsenic compounds. Chemically, silver reacts with sulfur to form black silver sulfide, causing discoloration when exposed to hydrogen sulfide gases. This reaction, however, is simply oxidation reduction chemistry and can also occur with harmless foods like boiled eggs or garlic. Such poison detection had high noise and low accuracy, failing to identify modern toxins like cyanide or agricultural chemicals. Yet historically, it represented an early step toward chemical sensing, primitive sensors long before electrochemical technology existed. Chopsticks are therefore more than eating tools. They summarize East Asian civilization through leverage, heat flow, friction, and chemistry. Each movement of lifting food becomes a quiet expression of physical thinking embedded within daily habit and cultural memory. Ironically, in an age of complex technology, one of humanity's most efficient machines remains two nameless sticks of wood. They contain no engines, fuel, or processors, yet maintain precision, speed, and sustainability across thousands of years. Chopsticks may be the simplest machine humans have ever built, and perhaps the smartest, amplifying not only force but culture itself.